गुड इवनिंग बच्चा लोग, कैसे हैं आप सब? So today again I am here to discuss another very important topic, which is gear and gear train. Theory of machine में this is going to play a very important role because every year examination में you can expect at least one or two questions beta, and especially from this gear train chapter questions are definitely asked. Always from this portion definitely you will have one question beta. Clear है? So गेट के पॉइंट ऑफ व्यू से, एग्जामिनेशन पॉइंट ऑफ व्यू से, दिस इज ऑल्सो वेरी इंपॉर्टेंट. एंड नाउ वी आर गोइंग टू डिस्कस व्हाट आर द मोस्ट इंपॉर्टेंट पोर्शंस फ्रॉम वेयर क्वेश्चंस कैन बी फ्रेम्ड, है ना. ऑलरेडी वी हैव डिस्कस्ड इन दिस वन शॉर्ट सीरीज, ऑलरेडी वी हैव डिस्कस्ड अबाउट मैकेनिज्म वाला पार्ट, ऑलरेडी वी हैव डिस्कस्ड अबाउट वेलोसिटी एंड एक्सेलरेशन एनालिसिस वाला पार्ट, एंड इन द सेम मैनर, in the most crisp manner, we are going to discuss about gear and gear train. And let me tell you what are the points which we are going to cover in this very crisp video. First of all, we will be talking about gear terminology because you have to be very comfortable at this portion. Otherwise, in this entire gear chapter, you will learn so many things. You will maybe you are able to solve the questions, but you will not get feeling of this chapter. So you must know what are the different terms, how do they look, है ना. And then we will be discussing about interference in involute gear. What is interference and how we can avoid this interference, how examinations make questions can be framed from this portion. Then we will jump directly into the gear train wala part because that part is most important. So we will be discussing about simple gear train, compound gear train, and epicyclic gear train. How questions are going to be asked. At the end of the video, I will also share two beautiful questions. You will get a glimpse that how questions are being asked and how you can very easily solve those questions beta. So chaliye, let's start. Acha, before I jump into directly some theory, let me give you a brief idea. And I am expecting that many of you who are watching this video have already gone through the gear and gear train chapter once in your life, है ना. So this is for your revision purpose. So what things you must know? The very first thing, that when we are going to have gear with us for making teeth, after so much research in this entire world, everybody has just agreed that bhaiya, there are only two profiles which can be used to make gear tooth. And when I say profile of the gear tooth, means if you see the gear, it will look something like this. ऐसा कुछ नजर आता है बेटा, something like this. Now this beautiful portion, this is something which I am saying profile of my gear. This is my profile of the gear. And for making profile of the gear, we have only two options with us. Either you can use involute curve, or you can use cycloidal curve. And only these two profiles which can be used to make gear teeth. Why? Because only these are the two profiles which satisfy law of gearing, and all those profiles which satisfy law of gearing, my dear students, those are called as conjugate profile. Conjugate profile. Getting my point? Now, now listen carefully. In our syllabus, we have only this involute profile. So we are going to discuss this portion in much detail beta. Cycloidal is not in our syllabus, so we are just skipping that part. Questions will be framed here only. Acha, involute curve ke bare mein, let me tell you one very important thing, that this involute curve, whatever teeth you have got, whenever I draw perpendicular on this involute teeth, normal drawn at involute curve, it will be perpendicular to its base circle, perpendicular to its base circle. I will show Where is this base circle? How does it look? I will show you this, है ना? अच्छा, those who don't know what is the involute curve, let me give you a brief idea about this also. Beta, involute curve, to draw involute curve for a circle, involute, although involute can be drawn for any shape in this world. If you are asking me, sir, for rectangle, can you draw involute? I can draw it. For a straight line, can you draw involute? I can draw it. For triangle also we can draw it. But for gears chapter, when we are talking about this gear chapter, obviously we are going to take circle as my shape, and for this circle I will be drawing my involute curve. Beta, this is the circle, fixed this circle, and if you are having a tangent which is rolling on the circle without any slip, this is the tangent, and if this tangent is going to have rolling on this circle without any slipping, at this moment this tangent is at this location, it is tangential at this particular point, somewhere here. Next moment this tangent has moved somewhere here, it has moved somewhere next, somewhere here, tangent at some other point. This tangent is going to have motion, and any point on this line, any point, if you take locus of any point, suppose if you are taking this point, so locus of this point is something which is called as involute curve for this circle. This circle is something which is known as base circle. Beta, this circle is something which is called as base circle. Acha, now let me tell you a simpler method to draw a base circle. This thing you can also try at your home. Beta, if you take a circle, anything which looks circular, you may take a glass also, take a thread and wound it tightly on that circle and put the circle on the paper, and now start opening that thread go open kariye, but and at the end of the thread put a pen so that you can trace out the path. The only condition is that when you are opening this thread, the tightness should be maintained, and if the tightness is maintained, can you believe, sir, whenever you will look, sir, suppose the thread is somewhere here, look at this point. Once you have opened this thread a little bit, thread looks something like this, somewhere here, it looks, this is the thread, this point has moved somewhere here in a circular arc, it looks something like this, open it a little bit more, next moment this point has moved, and now thread looks something like this, this point has traveled here, next moment open it a little bit more, thread is tangential somewhere here, and this point has moved somewhere here. So this curve which you are going to get, beta, this curve, this is something which is called as involute curve. For which circle? This is the base circle. Getting my point? This is something which is known as involute curve. Very easy. Acha, now this is quite clearly visible here. Everybody can understand. Yes, sir. Now we can feel it. Okay, sir, every point on this circle, on this involute curve, at any point, if you have drawn perpendicular, it have to be tangential to its base circle. Beta, this is the most beautiful property of involute curve, and because of this property only we are going to use it for making involute teeth. Now, when you have gear, let me show you one gear. This is a real photo of gear. Actual gear looks something like this. Sir, this is my gear, and in the circle there are, in this gear there are certain circles which we can imagine. Now, if you draw a circle which is passing through the tip somewhere here, this is something which is known as addendum circle. If you draw another circle which is passing through the bottommost portion somewhere here of the teeth, this is something which is known as a dedendum circle. Beta, if you draw a circle at which pure rolling motion can be imagined, this circle which is known as the pitch circle, and then there will be the base circle for which you have drawn your involute curve. That base circle is a little bit lower than this pitch circle. Beta, if I draw all these circles all together, it looks something like this. Let me zoom this diagram and give you a very, very clear idea. Beta, let me write. Sir, this bottommost circle, let me write, this is your dedendum circle beta, this is कहाँ लिख दें? Let me write here. Sir, this bottommost circle is dedendum circle, or many people also call it as a root circle. एक ही बात है. Nothing but same. This topmost circle, this is something which is known as addendum circle. This green color say which I have drawn, this is something which is known as pitch circle beta. And somewhere below the pitch circle you have your beautiful, this is your base circle. अच्छा, base circle के ऊपर again the same thing you have done. You know, you have taken a thread, opened that thread, and you have got some involute curve. Now everybody can imagine, you must know that involute curve which you are going to get, it will be above the base circle. Can you imagine beta? Sir, in this diagram we can easily see, sir, this is your teeth, and teeth ka that portion which is above the base circle, it is involute, but some portion of this teeth is also below the base circle. This portion is a non-involute portion beta. This portion is a non-involute portion. Let me write, above the base circle, this is the portion which is involute in nature. Law of gearing will be satisfied. This is the portion which is involute in nature, and below this base circle, this portion, a small portion, it is non-involute portion of the teeth. Clear hai? So in this teeth you are going to have some portion, above wala portion, above the base circle, you are going to have involute curve, involute teeth. If this part of the teeth is going to touch other part of the teeth, other gear's teeth, getting a point? Other gear ka teeth is going to come inside this gap, and if other gear's teeth is touching somewhere here, I have no problem. But if that gear ka teeth is going to touch inside, there will be a problematic situation. Getting a point? Now, how does it look? Everybody is clear now? How does it look? Acha, there are going to be certain terms which we must know. So in this entire gear, I have drawn only circles. So to know the terms which we are going to follow here, I will take a very small portion. For this entire gear, I am taking only 2-3 teeth. And here in that zoomed wala diagram, I will be showing you certain key important points. The same diagram I have taken beta. I have taken teeth which looks like this, and I have tried to make it in 3D beta. 3D mein you are also seeing this portion beta. Face width, etc. you can see in 3D portion. I hope this diagram is clearly visible to everybody. Now, if you look closely, sir, already I have said this topmost circle is the circle which is passing from the tip as your addendum circle. Bottommost say you are having dedendum circle. In between you are having pitch circle. Pitch circle ke niche somewhere you will be having base circle. है ना? अच्छा. On this pitch circle, for one teeth from this point to the same point of the adjacent teeth, this distance, if you are measuring this distance along pitch circle in the format of an arc, this distance is called as circular pitch beta. This distance is called as circular pitch. And from this point till this point, this is something which is known as tooth thickness. And from this point to this point, this is something which is known as tooth space. So can I say from this diagram, it is clearly visible to everyone, tooth thickness plus space, this is nothing but circular pitch beta. Pitch circle is that very important circle where you have seen your pure rolling motion. Whenever I will I have to show, whenever I have to show two gears which are meshing, I will show them just by their pitch circles. Simple. From pitch circle, the distance of addendum circle, radial distance, is something which is known as addendum, and from pitch circle till dedendum circle, this radial distance is known as dedendum beta. That's I have written. And from this addendum to this dedendum, this entire distance, yani ki addendum plus dedendum, it is something which is known as the total depth or height of the gear. Clear hai na? So these are few things which we are going to frequently use this in this entire chapter. Now let me write few formulas. I hope everybody is comfortable with these formulas. What formulas which we are going to follow here? The very first thing, which is known as pitch circle diameter. What is pitch circle diameter, sir? This circle which you have drawn, na, its diameter is something which we are going to use when we have to describe size of the gear, na. So I will. There are so many circles, and whenever we have to, in the market, whenever we have to describe size of the gear, we are going to use this circle as, as our consideration. Clear hai? By the diameter of this circle, we will describe size of the gear, pitch circle diameter. Clear na? Another term is there which is known as module. It is denoted by small m. mm में denote किया जाता है बेटा. This is described in mm. Unit is always going to be mm. It is defined as pitch circle diameter, whatever was the diameter, d by number of teeth. Getting my point? M is defined as d by t ka ratio. Diameter you have to put it in mm, and this t is your number of teeth on that entire gear. Always defined in mm. Another term is there which is known as the circular pitch. Let me write. Circular pitch. How does it look? I have just shown from one point of the teeth to the same point of the adjacent teeth, measured along this circular arc. This measured along the pitch circle in the format of circular arc. This is something which is known as circular pitch, denoted by PC, and it is actually defined as pi d by t. Pi d is nothing but circumference of this pitch circle, and total circumference divided by number of teeth. Once you will do, you will get to know how much is the circular pitch beta. How much is the portion of that circle periphery is associated with one teeth. Space plus thickness. Space plus thickness. Getting my point? अच्छा, एक चीज और, I hope everybody knows this. For meshing gears, few things must be same. One gear is meshing with another gear. Let me write somewhere for meshing gear. These module must be same. M1 must be equal to M2. Circular pitch PC1 must be equal to PC2. Clear hai na? And then there is also another term which is known as pressure angle. Phi1 must be equal to Phi2. If these are the situations satisfied, only then you can say that these two gears can be used together to transfer motion from one shaft to another shaft. Otherwise, I have one gear, I have another gear. If module is not same, if circular pitch is not same, if pressure angle is not same, I cannot use these two gears together at any cost. Clear hai na? So gear terminology mein these things are clear. Now I have to discuss from which part questions can be framed. Questions generally they will ask from the interference wala part, but before jumping directly into the interference, let me tell you how these gears are going to work. Involute gears ke point of view se I am talking, and how these gears are going to work beta. Very, very carefully. Suppose this is a pitch circle for pinion I have drawn, a small gear, and this is the pitch circle of gear which I have drawn. Here is the bigger wala wheel. It is known as gear. Let me draw it with another color. Yellow color से draw कर देते हैं बेटा, है ना? Centers को connect करने वाला line. This is the centers. line which is joining the centers. Let me call this is your point O1, center of pinion. This is your gear, center of gear. Point O1 is the center of pinion and this is the center of gear beta. These are the pitch circles. Whenever I have already told, whenever I have to show gears, I will not draw that complicated teeth wala diagram. I will just simply, I will show that from one gear motion is getting transferred to another gear by, and I will just show their pitch circles, and these pitch circles are rolling over each other. Wherever these two pitch circles are touching each other, that point is something which is known as pitch point. This is the point, pitch point bolte hain beta, this is P. And if you will draw a tangent here, it looks something like this. This is the common tangent which you have drawn at pitch point beta. Okay, na? Let me change its color. Now it's clearly visible. Acha. You will get, let me write, this smaller wala gear is my driver. And this is your driven wala gear. Now, driver ka teeth is going to insert some force on the driven wala teeth. So that obviously baat hai, you have connected motor here. Its teeth are going to have motion. And this moving teeth is going to apply certain force on the teeth of this gear. And then this gear is going to have motion beta. The direction along which force is being applied, driver ka teeth is applying certain force. And that force is along a direction which is at certain angle. That angle is something which is known as this line along which force is being applied. This is called as line of action, meri jaan. Line of action. Along this direction, teeth of driver has applied certain force on the driven wala teeth. Driven gear ke teeth pe some forces have been applied. Force F. And this angle between line of action and common tangent at pitch point, everybody knows that this is something which is known as pressure angle phi. Clear hai na? Acha. If I show base circle of pinion, it looks something like, the base circle of pinion will look something like this. I hope this is clearly visible. Very thin circle I have drawn. I hope this is clearly visible. This is the base circle which I have drawn beta. Now, how many of you can see? The base circle of the pinion is this circle which I have drawn. Line of action is touching base circle somewhere here. Let me call this point as point M. This is point M. And similarly, you are going to have base circle of gear also, beta. That looks like, sir, base circle of gear. Exact diagram we are drawing, beta. Base circle of gear looks something like this. Now, it is touching this line of action somewhere here at this point. This point is something which is known as point N. If I draw a line, this line, can you feel, sir, this is nothing but radius of base circle of gear? Can I say this? Similarly, if I draw point O1 to this point M, I have drawn a line. This is something which is the radius of base circle of pinion, beta. Simple si baatein hai. Nothing new. Now, contact starts when first time addendum circle of driven gear is going to touch this line of action, and that looks somewhere at this point. This is something jisko main bol raha hu. This is your point K, beta. Contact point K. Contact point Q will start here only. Contact point will start somewhere here. Why? Sir, because addendum circle of driven gear has touched this line of action at this point. You will have Let me draw. Careful, careful, careful. This is the addendum circle of gear, and it is touching line of action somewhere here. At this point, engagement is going to start. Pinion ka teeth and gear ka teeth, they will come in contact for the very first time at this point, and this point is something which is known as point K. Isko let me write as a point K. This is something. This is point K, beta. Let me write. This is something which is point K. है ना? And when pinion ka addendum circle is going to touch line of action, at that point you are going to have your disengagement wala point where both these teeth are going to disengage, and that is something which is known as point L, beta. This is point L. So from point K, both pinion ka teeth and gear ka teeth, they will come in contact. They will be together for some time, and at this point L, they will disengage, है ना? Like this. So can I say here? So from point K, contact will start. It will travel along this line, and at this point L, engagement is going to end, beta. Engagement will end. Getting my point? So this K to L distance, this is something which is known as path of contact, and everybody is comfortable with this. I'm not going to derive the formula, but let me write down. Sometimes examinations when they may ask, what is the path of contact? Let me write. Path of contact, which is actually from K to L ka distance, it can be written as Kp plus PL, and this Kp is, this has a formula. Kp is equal to, this Kp is equal to under root RA square minus R cos phi square, outside the under root minus ka R sin phi you are going to have. है ना? This is the formula. You must remember this formula, beta. RA is the radius of capital R. A is the radius of addendum circle of gear. Phi is the pressure angle. Capital R is the radius of pitch circle of this gear. Similarly, exactly same formula you are going to get for this PL wala part, which is known as, let me write, this is Kp is known as path of approach. Path of approach, and this is something which is known as path of recess, beta. है ना? Same formula you are going to get for PL, but in terms of small ra, small r, in terms of radius of pinions, beta. You must remember only one formula. Another formula you can easily write. That formula looks like under root small ra is square minus ka r cos phi square minus ka r sin phi. Simple si baat hai. How this path of contact is going to look from this point K to L. This line, this linear distance is something which is known as path of contact. Clear hai beta? Acha. If everybody is comfortable till this point, now we can discuss about interference. Interference kya hota hai beta? Sir, if I keep on increasing, suppose, if I keep on increasing my addendum circle of the gear, try to imagine beta, if I, earlier addendum circle was somewhere here, it was intersecting at this point, this was your point K. If addendum circle ka radius, if you keep on increasing, next time it will intersect somewhere here. Sir, yahan par intersect kar raha hai at this point. Can you feel point K is shifting backside, backside, backside. Till this point M, I have no problem. I have no problem. But can you imagine if radius of addendum circle of the gear or height of the tooth of the gear is too large, that now it is entering inside the base circle, and inside the base circle you had non-involute portion, so then you will be having problem of interference, beta. This must be avoided. Getting a point? Till this point M, if your gear teeth is going to touch till this point M, I have no problem. Beyond that, if your radius of addendum circle of the gear is very, very large, so bhaiya, beyond a limit, let me draw that limiting wala situation. Sir, till this much radius I have no problem. If this is your radius of addendum circle of gear, I have no problem. But if beyond that, if you are going to have radius of addendum circle of the gear, I will say your gear is going to do some interference at pinion wala teeth, because now this teeth is going to touch pinion at non-involute portion, which is not acceptable at all. Clear hai? Similarly, I will say पिनियन के केस में आई विल से पिनियन का टीथ कैन हैव मैक्स टू मैक्स दिस रेडियस. बियॉन्ड दैट, इफ रेडियस ऑफ अडेंडम सर्कल ऑफ पिनियन इज लार्जर देन दिस, तो कैन यू इमेजिन बेटा द पॉइंट एल विच यू आर गेटिंग समवेयर हियर, as you increase the radius, it will move on this line, and at point n, this is the point, dead point beta, dead end. Beyond that, if radius of pinion ka if the radius of addendum circle of pinion is increased beyond this value, I will say my pinion is going to do interference at gear wala teeth. So you have to control height of your teeth. Clear hai beta? And for this purpose, from here we will start calculating कि भाई ये बताओ maximum height of the tooth क्या हो सकती है, what can be maximum height of the tooth. Or in fact, one person suggested कि if you increase number of teeth on gear, the size of tooth decreases. So if you can provide minimum number of teeth on pinion and gear, तो फिर interference can be avoided beta. Getting a point? From here we start getting ideas. How do we reduce interference. Clear hai? अच्छा, examination में the very first question they can be asking you, how can we reduce interference? Let me write few methods how to reduce interference. Very clearly beta, there are few methods, just remember them. Examinations में it can be asked. Either you can do is undercutting, the very first one. Sir, undercutting means teeth looks something like this, and sir, why interference is happening? Sir, this is the base circle, niche you are going to have dedendum circle, this is the non-involute portion, and if somebody is going to touch here, interference is going to happen. So student suggested ki sir, why don't you do cutting already if there is no material here. So sir, if teeth is going to come here inside this portion, it will not have any material to interact with. This thing is called as undercutting. Up to certain level, interference can be avoided beta. Another thing, another suggestion was made by another student कि भैया we can do stubbing also. What is the meaning of stubbing beta? Stubbing का मतलब होता है, stubbing means, sir, you are having these large heavy teeth, and this teeth is going to enter into that zone where interference is going to happen. So sir, why don't you reduce height of this teeth? If you reduce height of this teeth, obvious सी बात है, it will not touch the opposite gear at non-involute portion. Clear hai? This method is something which is known as stubbing. Up to certain level, this is also acceptable. Another student suggested ki sir, you can reduce radius of base circle. Reduce radius of base circle, or simply pressure angle को you can increase beta. What I want to say here, you are having Suppose this is a random circle, and earlier you have made a base circle somewhere here. This is the base circle. So portion which is above the base circle is your involute. Non-involute portion is this. Somebody is going to touch here, interference will happen. The student suggested, sir, for the same gear, for the same teeth, what if you have selected your base circle somewhere here? New base circle. So sir, if this is my base circle, so above this base circle, this entire portion would have been involute. Now if somebody is going to touch, still you are having some involute, non-involute portion. If somebody is going to touch here, interference will happen. But sir, earlier in this entire portion interference was happening. Now you are having interference only at this part. Getting a point? But keep in mind, as you reduce radius of base circle, pressure angle is going to increase. Beyond certain limit, we don't accept that. Okay, na? So up to certain level, undercutting can be done. Up to certain level, stubbing can be done. Up to certain level, you can reduce radius of base circle. And another method is there, which is by increasing number of teeth. By increasing number of teeth. Acha, examination may sometimes theory questions can be framed. They will ask, which of the following method can be used to avoid interference? Sir, undercutting bhi karte hain. We also do stubbing. We also do. We also increase pressure angle. How? By reducing the base circle radius. We also increase number of teeth to avoid interference. Now the major question arises. Ki, please tell me how many teeth we should provide on pinion minimum. Pinion pe number of teeth you have to increase. But keep in mind that cost will also increase by increasing number of teeth. So we will provide just those minimum number of teeth from where our work can be done without any interference. And unnecessarily we will not increase number of teeth. Cost बढ़ रही है बेटा. So pinion में how many teeth can be provided so that it is not doing interference on the gear? For that you have to provide certain minimum number of teeth at pinion. Small t minimum, which is twice of AP divided by under root 1 plus G plus 2 sin square phi, and outside the under root you are having minus 1. Clear hai na? AP is the fractional addendum of pinion, G is the gear ratio, phi is the pressure angle. Similarly, now you will check for gear. By at gear, how many number of teeth? At least minimum how many teeth we should provide so that it is not doing any interference on the pinion. You will again calculate number of teeth on gear, capital T minimum, and this formula comes out to be twice of AG divided by under root 1 plus 1 upon G plus 2 sin square phi. Outside the under root you are going to have minus 1. Getting a point? So these are the formulas which you have to remember. Sometimes examinations में directly based upon these formula questions are being asked. बेटा पूछते हैं examinations में आपसे. ठीक है? This is minimum number of teeth required on pinion in pinion gear arrangement to avoid interference. Pinion पे how many teeth should be provided so that gear पे there should not be any interference, and then gear पे how many teeth should be provided so that it is not doing any interference on the pinion. Clear na? Sometimes a special arrangement is also there, which many of you know already. We call it as rack and pinion beta. Rack and pinion arrangement. And in rack and pinion arrangement, formulas ka format is going to change a little bit. Rack and pinion arrangement. Careful. Look, this rack is a straight gear. This rack is a straight gear, which you can imagine कि भाई this is a circle of infinite pitch. This straight line you can imagine as it is a circle of infinite diameter. So this gear, which is rack gear, you can imagine it as a very large infinite diameter wala gear, and uska a very small portion I have put in front of you. So very large gear is going to have infinite number of teeth. आई एम नॉट समथिंग विच इज हैविंग इनफाइनाइट नंबर ऑफ टीथ टेक्निकली, है ना, दिस इज हैविंग इनफाइनाइट नंबर ऑफ टीथ. We will calculate on pinion how many teeth should be provided. तो pinion के लिए again you are going to have formula small t minimum which is written as twice of AR divided by sin square phi. Getting a point? Just remember this formula and you can use this formula to get your answer in the examination. Now, while giving your answer, you have to be a little bit careful, beta. Examination mein suppose if you have put all the values here and you have got some answer, sir 17.09 aa gaya answer. Number of teeth cannot be in fraction, beta. Either you can choose 17 or you can choose 18. But what should be your answer? This is saying at least 17.09 teeth you have to provide. So, but a higher number, higher integer value you have to choose. 17. If 17.09 comes your answer, so you will go for next higher value. Next integer you have to choose, beta, है ना? So you will give that 18 is my answer. Clear है ना? Simple सी बात. Gears की दुनिया में you must be very comfortable with the terminology वाला part. You must know the concept of interference. है ना? Here I have only discussed what are the formulas, how these gears are going to mesh, है ना? But you know, in detail, if I have to talk about the gear chapter, so it will take at least, again I am saying it will take at least not less than gear and gear train combined, not less than 10 to 12 hours, beta. Okay, so I am trying to keep this video very short, crisp and informative so that revisions के point of view से this can be very beneficial for everybody, है ना? So path of contact के लिए you have certain formulas, you must remember them. In interference के लिए you have certain formulas. minimum number of teeth के लिए you must remember them. Rack and pinion में you have certain formulas, you have to remember them, beta. Now, next we are going to talk about gear train. What is the gear train and why even we need this? Why do we even need this? देखो, if I say that I have only 2 gears, no, I have gear 1, it is meshing with gear 2. This is gear 1, this is gear 2. So, but everybody knows that at this small gear I have given my input. This is your driver and this is your driven, beta. Clear है ना? So omega 1 by omega 2, everybody knows that this is teeth का reciprocal T2 by T1 होता है. And in the same ratio as you are having teeth का ratio, similar ratio में you are going to have radius का ratio. So you will get one idea here कि sir velocities के ratio radius के reciprocal भी होते हैं. Getting a point? So can you imagine, sir, if you have to, you know, I have provided some omega 1 1000 rpm and output में speed को if I have to reduce half 1000 rpm input में and output में if I want to get 500 rpm, तो radius double करनी पड़ेगी. I have to double the radius of output gear. Now, with the same logic, imagine करिए, if input पे I have given 1000 rpm and output की speed I want 10 times smaller, 1000 rpm input and 100 rpm output में if I want, so 10 times decrease in the speed I want, so 10 times increase in the radius I have to provide. मतलब this small gear का radius will be very small, 1 centimeter का radius, and output वाला gear का radius will be 10 centimeter radius. It is very large. What if I have to, you know, I have to give 1000 rpm input and output में I want 50 times smaller, you know, 50 times smaller values of velocities. So फिर diameter, this dimensions, size will be 50 times larger. अब imagine करिए बेटा, there may be certain applications where I want कि भाई मोटर के torque I want to increase. अब torque को increase करना है, that means velocities को reduce करना है. To reduce velocities, size increase करना पड़ेगा. You have to increase the size. 50 times टॉर्क इंक्रीज करना है तो 50 टाइम्स यू हैव टू रिड्यूस द स्पीड, दैट मींस 50 टाइम्स size must be increased. अब a very small gear, input gear, it is connected with another output gear which is 50 times larger. This is made up of iron, this is also made up of iron. Can you imagine a chotu sa gear, very small gear is connected to a very big gear, 50 times larger gear. It is having, this small gear is having a small teeth. Do you feel it is having capacity to rotate that big gear? अरे भैया inertia का problem is going to be very high here. This big size gear is having very high inertia, and that's why whenever we need very high speed ratio, let me write, for very high speed ratio, just by using these two gears we cannot survive. For very high speed ratio we need combination of gear, and that combination of gear is something which is known as gear train. Beta, this is something which is known as gear train. Now everybody is comfortable that why do we need gear train? Just by using two gears काम नहीं चल रहा था, है ना? Our purpose was not getting fulfilled. Speed ratio, sir, up to certain level, speed ratios of 2, 3, 4 we can get, है ना? इनपुट में you have given some speed, आउटपुट में स्पीड को हाफ कर लिया, 1/3 कर लिया, 1/4 कर लिया, आई एम ओके, बट 1/10 कर लिया, 50 टाइम्स रिड्यूस कर लिया. These things are not possible. क्यों नहीं possible है? Why it is not possible? Because otherwise size में भी तो similar changes you can see now. Size is small and output का size is 50 times larger. That becomes a problem for you. Clear है बेटा? अच्छा, so you are going to have input वाला gear, main driver. You are going to have output वाला gear, and in between you are going to have some more gears, and this entire combination is going to be called as gear train. Beta, you may have simple gear train which looks something like this. Suppose here this is your main driver, it is rotating about its fixed axis. This is your main driver, and this is your main driven. Beta, main driven gear. You have given input here and you are collecting output from this gear. Beta, let me write some name. This is your gear number 1. Beta, this is your gear number 2. 2 is driving 3, 3 is driving 4. Why is this called as simple gear train? Because this is the input shaft, you have one gear. This is the output shaft, you have one gear on that also, and in between you have connected these two gears with the help of multiple gears. Now the condition only is this, that each intermediate shaft is going to have only one active gear. Beta, all these gears are something which is known as, all these gears are known as intermediate gears. Intermediate gears. Getting a point? Simple सी बात है. अच्छा, let me tell you one trick. Let me tell you one trick. देखो, in simple gear train, a very big condition is there कि भाई gear 1 is meshing with gear 2, so meshing gears का module must be same. 1, 2 must be having same module. Now 2 is meshing with 3, 2 and 3 must be having same module. Sir, module of gear 1 must be equal to 2, and you are also saying that 2 and 3 must be same because they are meshing. So भाई M2 और M3 भी same होना चाहिए. This also must be same. Now you are saying that 3 is meshing with 4, तो 4 and 3 का भी module must be same. अरे भाई M3 M4 must also be same. Very big constraint is going to be there. This is a big condition. Imagine करिए market से you have to purchase certain number of gears. I will give you a list. You go to the market and find out gears of 10 teeth, 20 teeth, 50 teeth, 80 teeth. I have given you the list, and the condition is purchase all these gears, but module must be same. Every gear must have same module. This is the big condition. Beta, getting my point? Okay. Anyway, you have calculated all the gears in the hope that all these gears together will give a surprisingly very large speed ratio. Sir, speed ratio, which is defined as angular velocity of main driver divided by angular velocity of main driven. Now let's check what is the speed ratio which you are going to get here. Number of teeth on this gear 1 is the T1 teeth. It is having T2 teeth. It is having T3 teeth. It is having T4 teeth. Okay. Let me write down here. Simple gear train में each intermediate shaft is having only one active gear. Each intermediate shaft has only one active gear. Careful. Main driver speed ratio निकाल रहे हैं ना. Main driver omega 1 divided by omega 4. This ratio I am interested in. How can this be written? 1 is driving 2, so T2 by T1. T2 by T1 multiplied by, now 2 is rotating. 2 is driving 3. So sir, T3 by T2. Now 3 is driving 4. So T4 by T3. How I have written? देखो, already we have understood this. Angular velocities के ratio omega 1 by omega 2 teeth का reciprocal होता है. This is going to be reciprocal of the teeth. And that's how we have written from omega 1, from this gear 1 to gear 4. You have to write down the equation. So omega 1 by omega 4. And now just follow the path. Gear 1 ने 2 को drive किया. Gear 1 drives 2. So T2 by T1 reciprocal. Now 2 is driving 3. So T3 by T2. Now this 3 is driving 4. So T4 by T3. Getting a point? This is how you have written this equation directly. Examinations में you will follow this method. You will follow this method बेटा. ठीक है? अच्छा, few things are getting cancelled also. मेरे ख्याल से this T2 से T2 will get cancelled. T3 will get cancelled. क्या बचेगा? You will be left only with omega 1 by omega 4. अरे वाह सर, omega 1 by omega 4 is coming out to be T4 by T1. बेटे, as you can see, you have purchased so many gears in between also. But these gears के teeth are not even coming into the formula of speed ratio. They are not participating here. Very big condition that every gear is having same module. They must have same module. But they are not participating here. That's why this gear train is called as worst gear train. And these intermediate gears are also called as, these are known as, but इनको बोलते हैं, these are called as idler. Why? Because they are not participating. Why? Because they are not participating in, speed ratio का formula. They are not altering the motion. They are just transferring whatever they have got from gear 1. It has transferred to 2, 3 and 4. That's it. They have not done any modification in the velocities. Clear है मेरी जान? अरे omega 1 by omega 4 is equal to T4 by T1. It is as good as कि sir, using this entire combination क्या फायदा हुआ? If I have used, this is my gear 1, it is driving gear 4 directly. No one is in between. कोई नहीं है. तो भी तो I will be getting omega 1 by omega 4 as T4 by T1. Getting my point? Either you connect gear 1 and gear 4 like this, or in between so many gears you have connected, results are going to be exactly same. That's why this gear train is of no major use. There is you will never find any practical any big use. Clear है ना? हाँ. If you have sometimes if you have requirement कि भाई input gear and output gear के बीच में a large center distance is there, so speed ratio में you will not get any considerable result. But ठीक है, large center distance को easily you can connect by small gears. Getting a point? Now, the second thing, a student said कि sir, the problem was because you have taken only one active gear on intermediate shaft. That's why it is not coming into picture. Now, suppose this is your gear number 1 where you are going to give your input. This is your main driver beta. This gear 1, and this is something which is your, suppose gear 1, 2, 3, 4. This is gear number 4. You are going to collect your output from here, and this is your main driver beta. Getting my point? You have given input here. It is driving this gear 1. Gear 1 is driving gear 2. 2, and on the same shaft you are having another gear which is gear number 3. They are rotating on the same shaft, same velocities. These two gears which are on the same shaft, these are known as compound gear. Gear 2 and 3 are compound. And if in your entire gear train, even if you have one shaft which is having compound gears, this entire gear train will be called as compound gear train. What gear is compound? Sir, that those gears which are on the same shaft are known as your compound gears. Clear now? Gear 1 is driving 2, 2 and 3 are on the same shaft. Now 3 is driving gear 4. Now, if you'll, this is something which is known as compound gear train. And let's see what changes you are going to have. Gear 1 is, just check from gear 1 and gear 4. Speed ratio mein, do we have any change? Let's check. Speed ratio. Now, if I calculate omega 1 by omega 4, you will get some considerable result. How do I write this equation? Now, everybody is comfortable. Gear 1 and 2 के भी 1 से 2 motion जा रहा है. Motion is flowing from 1 to 2. So, omega 1 by omega 4 you have written. Motion is transferring from 1 to 2. So, T2 by T1. 2 is rotating. Now, 3 is also rotating. But they have the same velocity. Now, 3 is driving 4. 3 is driving 4. So, by T4 by T3, reciprocal of the teeth. That's how you write the equation. Simple. This is the equation which you have written. Acha, no teeth is getting cancelled. No teeth is getting cancelled. Now can you imagine beta? देखो, main driver, main driven. These teeth are in picture, and in between whatever compound gears you had, sir, T2 and T3, these are also participating in the formula. Getting my point? This is a very beautiful gear train beta, compound gear train. Getting my point? Examination mein what they will do, they will give you this kind of arrangement and they will ask you find out velocity ratio, speed ratio find out karo. How you can find out speed ratio? Just teeth. How do we write this equation? If you know all the teeth, very easily you can find out what is going to be the speed ratio. Sometimes input ka speed they will be giving and output ka speed they are going to ask. Very easily omega 1 is given, omega 4. Very easily you can identify if you know all these number of teeth. If you know all these number of teeth. ठीक है ना? अच्छा, इसी में कंपाउंड गियर ट्रेन का ही देयर इज अ स्पेशल केस. बाय नेचर दिस इज कंपाउंड. By nature this is compound. But the only one thing which is special here, that suppose this is your input gear. Gear number 1, it is driving gear number 2. 2 and 3 are compound. 3 is driving 4. The special thing is, ki sir, you are collecting output from here. The special thing is, ki sir, input and output ka axis of rotation is same. Input and output gears ka axis of rotation is exactly same. What was the situation here, sir? Yahan par axis was different. It is rotating about this axis. It is rotating about this axis. What is new here, sir? Here, axis of rotation of input and output, both gears are same. Nature wise, this is also compound. Why 2 and 3 are compound? This is also compound beta. But due to this, कि भाई input and output gear का axis is same. This is also known as, by nature, this is compound. Special case है, this is called as reverted gear train. Reverted gear train. And I don't need to explain this. Reverted का मतलब क्या होता है? Everybody is comfortable. Input को you have given motion and on the same axis you are going to get your output beta. How do we solve this? I again need not to discuss. Sir, omega 1 by omega 4 you have to identify. Very easily you can write omega 1 by omega 4. Same तरीके से. 1 is driving 2, तो T2 by T1. N2. 2 घूम गया. This 3 is also rotating. 3 is driving 4. So T4 by T3, that's it. If you know all these number of teeth, very easily you can tell me, what is the speed ratio. If omega 1 is given, omega 4 you can also calculate, but very easily you can tell me how much is the omega 4. Acha. You can tell me very easily the answer, but provided all teeth must be known. Sometimes they will miss certain teeth. कुछ तो teeth miss कर देते हैं. And if any teeth is missing, you can take help of radius. Bete, can you imagine? Sir, this is the radius of pitch circle R1. Radius of pitch circle, this is R2. Radius of pitch circle here, this is your R3. And radius of pitch circle here, this is your R4. You will get some relation. In your diagram, you will have to identify what relations can be seen. You will get some relation. Suppose here from this diagram, I can see R1 plus R2, this radius, this distance and this distance, they look similar because this axis and this axis, they are parallel to each other. So can I write from my diagram, can I write R1 plus R2? It looks same as R3 plus R4 beta. Acha, radius ko everybody knows. We can also write, sir, module is equal to d by t hota hai. We have just seen. Diameter ko we can write as twice of radius r. So can I write r can be written as mt by 2 beta. Wherever you have radius, module pata hai, number of teeth pata hai, so very easily you can find out how much is the radius. R1, R2. Acha, these two gears are meshing with each other. M1 must be equal to M2. And suppose this value is M. Similarly, 3 and 4 are meshing. So, bhai, M3, M4 must be same. Suppose this value is M dash something. Can you write R1, R2 को क्या लिख सकते हो बेटा? M1 T1 by 2 plus M2 T2 by 2 is equal to M3 T3 by 2 plus M4 T4 by 2. Getting my point? M1 M2 same है बेटा. M same as M common आ जाएगा. 2 से 2 will get cancelled. You will be having M T1 plus T2 is equal to M dash T3 plus T4. You will get some relation. Something like this. ऐसा कुछ relation you are going to get बेटा. ठीक है ना? ठीक है. If somebody is saying कि भाई if M and M dash they are also same, question is even more simple. M dash will get cancelled and you will be having T1 plus T2 is equal to T3 plus T4. And believe me, but this looks exactly same. Radius mein you had some relation. If all modules are same, you will have exactly same looking ditto photocopy type of relationship between teeth also. But again, listen carefully. Examination mein students are going to commit mistake here. Why? Sir, they will say, students will say, sir, you have told us whatever is the radius relation, that will be same as teeth relation. But hey, I have put a condition also that if all the modules are same, in that case, radius relation will exactly replicate into teeth. Otherwise, if module are not same, so you will have some relation, but modules M dash will also be there in the picture beta. So you have to be extra cautious here. ठीक है ना? अच्छा. Another beautiful gear train is there, which is known as epicyclic gear train. Epicyclic gear train का मतलब क्या होता है? Epicyclic means, epi का मतलब होता है, this means axis, and cyclic means rotation. If all the gear trains which we have, seen here, all the gears were rotating about their fixed axis. But if any of the gear ka axis starts rotation about another axis in your gear train, epicyclic nature introduces, and that train becomes your epicyclic gear train beta. For example, I have a gear something like this. This is meshing with a small gear, if these two gears are rotating about their fixed axis, this is a simple gear train, beta. These are simple combination of gear. We know how to solve this, beta. We know how to solve this. Very easily we can write down the formula is कि sir omega 1 by omega 2 it is T2 by T1 होता है. We know this. Now if one gear is rotating about fixed axis but other gear का axis is free, this is free, ये free है बेटा. Gear can have rotation about this axis and this axis can have rotation about some other axis. Getting my point? Now this gear is not rotating, it is revolving. है ना? Rotation and simultaneously its axis is also having motion. Just same as Earth revolves about Sun. Earth is spinning about its axis and it is also having rotation about Sun. This kind of motion you are going to get. Acha, to accompany this kind of motion, a arm is used, beta. Practically, a arm is used. Arm can have rotation about this fixed point. Arm ka rotation will allow this axis ka rotation. Arm is carrying this axis. Arm is rotating, that means this axis is having motion, and axis ke about that gear is also having certain motion. Getting a point, beta? Now, believe me, beta, when these two gears were fixed about their fixed axis, they were rotating. Till that time, I can use very easily omega 1 by omega 2 is equal to T2 by T1. But now, once arm has started rotation, these formulas are not going to give you answers. These formulas are not even valid. Why? Why I am saying so? Suppose for a moment, arm is not rotating, arm is fixed. Both these gears are rotating about their fixed axis. I can write omega 1, this is gear 1, and this is gear 2. Omega 1 by omega 2 is T2 by T1. If I hold this gear 1, gear 2 will automatically stop. If omega 1 is your 0, omega 2 have to be 0. No other option they have. But here, if I make my gear free, this gear 2 can have, revolution, rotation, as well as its axis can have motion here. Now in this situation, even if I make my gear 1 fixed, even if I fixed it, imagine kariye, even if I fixed this, gear 2 can travel, it can have rotation and its axis can have motion. So even if omega 1 is 0, omega 2 non-zero you are going to get. And that's why I am saying these formulas we cannot use, beta. We cannot use these formulas. Clear hai? Formula mein a little bit modification can help you a lot. How we are going to do this modification? By using common sense, beta. What is the common sense? One student said, sir, due to this arm ka rotation, this formula is not applicable, na? If I will sit on this arm, now I am also rotating with this arm. So, sir, with respect to me, this bacha, with respect to this small child, arm ke rotations are not visible. Kyun? He is also rotating with the same speed. Now, if he can't see rotation of arm, this guy can apply this formula, beta. Yes. This student, this guy cannot see rotation of this arm. So he can very easily use formula here. Very easily. But believe me, whatever velocities, omega 1, omega 2, this guy is going to tell you, these are not exact velocities. These are relative velocities. Relative velocities with respect to what? With respect to arm. Because this guy is also rotating, beta. So omega 1 by omega 2, instead of writing this, you will write omega 1 ka speed with respect to arm divided by omega 2 ka speed with respect to arm will be equal to T2 by T1. And this time you have to take care of direction also. Dekho, earlier cases mein I am very much comfortable ki sir, if it is rotating clockwise direction mein, so external meshing hai, it will rotate anti-clockwise. This is anti-clockwise, same shaft mein hai, this is anti-clockwise. And again, external meshing ho rahi hai, the direction will get reversed, this will rotate clockwise. Very easily I can tell this. है ना, डायरेक्शन के लिए I will not be dependent upon the formula, but here I cannot be sure about anything. I literally cannot tell anything. So here you will take care of sign, you will take help of mathematics. According to mathematics, external gearing, if you are going to have, you will use a negative sign and a direction will be reversed. And if you are having internal gearing, you will use a positive sign. Means omega between gear 1 and 2 meshing is there, 1 is driving 2, so T2 by T1 you have written, but you will put a minus sign. Why? Because sir external meshing हो रही है ना, डायरेक्शन रिवर्स हो जाती है, so that's why you have written minus sign here. Internal meshing होगी तो you will put a plus sign here. And once you have put all the minus plus everything, put down all these values, omega 1 ka some value they have given, omega arm ka some value they have given, and then you can very easily solve these kind of questions beta. I will tell you how do we solve it. I will tell you. Clear है? Epicyclic gear train. और epicyclic gear train में a very unique gear train is there, which is also epicyclic है, but this is also known as a planetary gear train. Let me write, this is something which is known as planetary gear train, or some people also call it as sun and planet gear train. Careful beta. You are having, this is your sun gear, this is rotating about certain axis, about the same axis your arm is going to have rotation. This is your arm beta. Arm is carrying another gear which is known as planet gear. This is planet gear, and this planet is meshing with another gear which is known as a ring gear. Clear है ना? So examination में very, some most of the time questions will be asked from this planetary gear train, epicyclic gear train. Clear है ना? अच्छा, one thing is common sense वाली बात बेटा. You can see sun is meshing with planet, the module is same. Planet is meshing with ring, module is same. इसका मतलब no need to say, examiner will never tell you. You must understand कि sun, planet, ring, module are same. All gears here have same module. I need not to examiner need not to give it in exam. They don't need to write this in your question beta. It is common sense वाली बात. This is self understandable कि भाई सारे gears mesh कर रहे हैं, so they are going to have same module. Or if they are having same module, so whatever is the relation between their radius, same teeth में you are going to have. Radius में क्या relation दिख रहा है सर? sun का radius plus diameter of planet is the same as ring का radius. Can I write radius of sun plus twice of radius of planet is equal to radius of ring beta. Same teeth में you are going to have teeth of sun plus twice of teeth of planet is equal to teeth of ring beta. If some teeth is missing, so you can also find out from here. If some teeth is missing, you can find out from here. Clear है ना? चलो, gear chapter and gear train में only these are the questions which are generally asked. Now before ending this short crisp video, I would like to tell you, I would like to discuss two questions just to give you more conceptual clarity. Acha, everybody, those who are watching this video now, please pause this video. I'm just outside the board. Pause this video and think about this question. According to you, what is going to be the answer beta? I am discussing here, but for a moment take a pause and try to think which is going to be possible answer here. Okay, guess कर लिया? Now let me tell you. Question में what they are asking, consider the following specifications of gear A, B, C, D. 4 gears they have given. What things they have written here beta? They have discussed about how many number of teeth. Gear A has 20 teeth. What is the pressure angle? 14.5. Module कितना है? 1. What is the material? Sir, steel. Okay. Similarly, gear B के बारे में they have said 60 teeth है, 14.5 pressure angle है, module is 3, material is this. Gear C के बारे में and gear D के बारे में they have given some information. They are asking which of these gears form a pair of spur gears to achieve gear ratio of 3. Gear ratio of 3 के लिए which pair can be used? Gear ratio 3. अच्छा, what is the gear ratio beta? This is capital T by small t. number of teeth का ratio must be 3. Out of these, which gears can be used? Examiner wants you to critically think about certain conditions. Acha, A, B, C, D, they have few things are made up of steel, few things are made up of brass, steel. Check करो बेटा. As such कोई condition होता नहीं है. There is no such condition that meshing gears का material it should be same or not. There is no such condition. Material may or may not be same. Let me write for meshing gear. For meshing gear, material may or may not be same. जरूरी नहीं है. Addendum, value of addendum, even dedendum, these value may or may not be same. There is no such compulsion. Now, if they are given same, okay. If they are not same, okay. They can form a pair, definitely. But for meshing gears, pressure angle, circular pitch, module, diametral pitch, these values must be same. For meshing gears, these values must be same. Otherwise, they will not form a pair. Now, check करिए बेटा. Check करिए. Capital T by small t का ratio you want 3. Gear ratio 3 you want. So, one gear is having 20 teeth. One gear is having 20 teeth. Other is having 60. We can work. No, चलेगा sir. 20-60 ratio is coming out to be 3. I am happy. Pressure angle is also same. I am more happy. But what? Arey sir, module is 1, module is 3. They cannot form a pair. A and B cannot form a pair. Getting my point? They cannot form a pair. Now, look at B and C. Sir, B is having 60, this is having 20. 20-60, again, ratio of 3 you will get. Pressure angle, array, sir, pressure angle is not same. They cannot form a pair. Module same hai, but pressure angle is different. They cannot form a pair. Now, look here. C and D. 20-60, but sir, pressure angle is different. Nah, they cannot form a pair. Now, look here. Look here. Look at A and D. 20 and 60. They can form a pair. Yes, sir. 3 ratio you are going to get. Pressure angle 14.5, 14.5, exactly same. Module 1 exactly same. Arey wah. Sir, material के बारे में do I need to check? No, beta. This is steel. This is steel. They are same. I'm happy. If they are not same, doesn't matter to me. Getting a point? So which gears can form a pair to give gear ratio of 3? Sir, A and D we are going to use. A and D. Option B, Bombay, is going to be correct, beta. Option B seems to be correct. Clear hai na? So how examination mein questions are, this question is have been asked in gate, beta. Question already have been asked in gate. Okay. One last question for epicyclic gear train. Again, I am outside the board. Just have a look and pause the video and try to solve this question. Try to solve this question. Now, I hope you have got your answer. Now let me tell you. What is the correct answer here? Examination mein, question mein, what they have given. The arm OA of an epicyclic gear train shown in the figure. Arm OA. This arm OA of an epicyclic gear train revolves counterclockwise about point O. Point O ke about this is going to have rotation with an angular velocity of 4 radian per second. Angular velocity of arm they have given. Kitna hai beta? Angular velocity of arm they have given 4 radian per second. Anti-clockwise, counterclockwise. Hai na? Okay. Both gears are of the same size. Both gears are of the same size. That means gear B and gear C, they are having same teeth. Same size, same teeth. The angular velocity of gear C, they are asking angular velocity of gear C, you have to calculate if gear B is fixed. Angular velocity of gear B, ये तो zero है, this is fixed बेटा, है ना. How do we solve this question बेटा? Epicyclic gear train में I have already told omega 1 by omega 2 T2 by T1 you cannot write. What you can write? Relative velocities के terms में you can write easily equation. Omega from B to C you can write equation omega B by omega C with respect to arm, with respect to arm will be equal to कितना हो जाएगा? How much this is going to be? B to C, तो TC by TB. External meshing है तो I will put a minus sign here. Now put down the values beta. Omega B, how much they have given? Sir, 0. Omega B का value they have given as 0. Put down 0 here. Arm का speed how much? 4 radian per second anti-clockwise. Let me write. Sir, clockwise को I will write it as positive. Anti-clockwise को I will write it as negative. Sir, I want to denote opposite signs. मतलब clockwise को negative, anti-clockwise को can I put it positive? Your wish beta. Your wish. But one thing you can take it as positive, other thing you have to take it as negative. Put down this value. Anti-clockwise को I am considering as negative. How much is the value of arm का speed? 4 anti-clockwise, यानी कि -4 you have to put here. Arm का speed -4 you have to put here. Put down the values. Number of teeth, sir, B and C same teeth, so TC by TB is nothing but -1. Solve करिए, what you will get? Sir, this is 0. This is 0. Minus -4 यानी +4 divided by omega C +4 is equal to minus का 1. Try to solve this beta. This omega C +4, ये minus this side -4, तो omega C how much? Minus का 8. Minus का 8 radian per second. What is minus representing here, sir? Minus is representing that gear C is also rotating in anti-clockwise direction. Anti-clockwise direction. Getting my point? Which option is correct beta? Option B, Bombay is correct. Simple सी बात. So this is how you can solve epicyclic gear train के questions beta. ठीक है? So that's all. This is what examiner is expecting from you in gate examination. You must be very comfortable. Again I am repeating, you must be very comfortable with what is path of contact, what is arc of contact, terminologies क्या होती हैं examination में. These things are going to help you a lot. Interference, what is interference, how it happens, how does it look, how to avoid it, है ना. What are minimum number of teeth के formulas, you must remember them. And most of the time numericals are being asked from gear train. Gear train में we have already seen compound gear train क्या होता है, epicyclic gear train क्या होता है, simple gear train क्या होता है, ठीक है ना. How do we write speed ratio का formula in terms of teeth? We are comfortable. Simple gear train, compound gear train में same method you will follow. Epicyclic में बस only in terms of relative velocities you have to write. Just take care of plus minus also, है ना. Just try to avoid all small mistakes, calculation mistakes, sir, plus minus miss कर दिया, and then you can solve all the questions बेटा. ठीक है. This was just a revision वाला video. Once we will meet in our detailed descriptive classes, तो फिर है ना, we will learn this chapter in much more detail बेटा, much more detail. Approximately 12 hours, 15 hours we will discuss about this gear and gear train. ठीक है. So let's stop here. अभी फिलहाल के लिए we are going to stop. We will meet in another video with another short and crisp content वाला video which is going to help you a lot in examination beta. So see you in the next video. Till that time, thank you बच्चों. Goodbye. Love you all मेरी जान.